With the working installation of MetNet Maker, we can start to think about creating our first simple network. And a good place to start, if we want to look at a network to create, is on the flux balance analysis site on Wikipedia, where there's an example of not only a network on the left, but also a network that's been prepared for flux balance analysis on the right. So let's create those networks. Just saving the picture here so that I can look at it whilst I reconstruct the network. So on this one I can just move that over to the right and still have room for MetNet Maker. And this is the installation that we've already populated. So it does take a little bit longer to load up once it's full of the Kegliggen database. So we're going to start by putting in the reaction at the top left. Now in this example we're actually at 1600. Is R0 1600. And we could just type that in because when I made the site I actually put in the keg reaction numbers. But let's imagine that we don't know what the keg reaction number is. We might have some information, EC number or something, but in this case we know that the reactant name and the product name are both beta-D glucose or glucose 6-phosphate in this example. So we can type in here, we're showing different ways of filtering down. In this example, glucose-6 is not the way to write it, and we can see by looking that we want to have a space to the 6. So we type that in, and we can see that there are 3 different reactions in this case that fulfill that condition, and this is the one where the ATP and ADP, and it goes between those 2. So we can select an EC number and add that to the selected reactions list. And I showed right at the start that if you click on the open in separate window part of the selected reactions list, then you see a much bigger display of what reactions you've selected, but for now we just want the compact view whilst we're adding. So we remove the filters and we start looking for the next reaction. So to speed things up, I'll just select the reactions that I know, and these are all reactions that are taking place in the cytosol, and they're all reversible, so we can leave the compartment and initial kinetic type as it is. So we add the reactions. And you can see how quickly you can start to build up a network in this way. Obviously it takes a little bit longer if you don't already know the keg reaction numbers, but you can filter by so many different types, compound pathways, EC number, reaction ID, that you can very quickly get there. So we've come up against a bit of a problem here. Searched for 4479, the reaction, and it doesn't look right. So we're looking in the reaction view at the bottom, and it's certainly not fructose. So there's obviously been a problem somewhere. So I'm just going to look for any reaction that starts with beta-D fructose and ends with beta-D fructose. So there's quite a lot of reactions that start with beta-D fructose, and we could just look through all of them until we found the reaction that we want. But we know that this one also ends with beta-D fructose, in this case 1,6-bisphosphate. This looks quite close, the top one, except it's a diphosphate to orthophosphate, and we want ATP to ADP. So we just have a look through them all in the reaction view at the bottom. This one looks good, and it's also implicated in the glycolysis pathway. I suppose we could have filtered for that whilst we were looking for these reactions. And again, just add it in the cytosol compartment with the reversible 500 type. That means that the positive flux is constrained to 500 and the negative flux is constrained to 500. And we can quickly save this out. So let's call this top of glycolysis. We've clicked the export as Excel button, and it exports what we've got. And you see that the Excel export is actually the same as what you would get in the full view of the selected reactions window. So these are completely the same, and we can actually edit in MetNet Maker with the selected reactions window fully open, but for quick editing it's probably best not to. You notice that in order to select reactions in MetNet Maker, you just click on the left, and in this case we're actually now going to export the files, in this case as an SBML level 2 version 4 file. The level 2 version 4 export is very similar to the level 2 version 1 export, but unfortunately the version of Cobra Toolbox that I use and most people use, 1.3.3, will crash if you try and load this file with the version 4 tag at the top. So if you just choose the level 2 version 1 tag, then you'll have no problems. And you see what we've got here is we've got an SBML file with constraints in it that fully reflect what we had in our selected reaction zone. So this is ready for use with any SBML compatible software. So let's go back to MetNetMaker now, because we want to prepare what we see on the right hand side, and this is the way that you need to prepare a network for flux balance analysis. You need to put in, first of all, the ability for certain products to get across the boundary. In this case we'll pretend this is a cell membrane, and also the possibility for compounds to be created from the boundary. So in this case we're going to think about having something that moves metabolites across the boundary and another reaction that creates the metabolites from a pool or a source external, or a sink external to the system. So we need to create a new reaction, and we do that by either clicking on the reaction creator button at the top in the ribbon, or we do it from create new reaction from in the reaction picker. So the first thing we're going to do is create a reaction that moves alpha D glucose from outside of the cell, that's in the extracellular compartment, into the cytosol. You can check for conflicts just to check that this reaction hasn't been defined already, and it hasn't been. So in this case we're going to select a reaction ID. Now, how you choose to define these reaction IDs is up to you. If you're creating a big model, you probably want to think of some system that's going to be easy to remember. In this case I'm just going to say example, and we'll see later how I've actually really defined these things. And you can put in a reaction name here, anything that you like that will help you remember what this reaction is. And here it is moving alpha D glucose from outside of the cell into the cytosol. And that's our first reaction that we've created. We just click on the left and press the delete key to delete entries, and this happens on all tables within MetNetMaker. That's the way that you delete things from within tables. Just click on to the left of the entry, press the delete key, and you can also do that with multiple selections. So now we want to do a similar reaction for beta D glucose. We see that it's there, and we had a reactant in the extracellular compartment and a product in the cytosol. And we can name this similarly to the last one. And now let's just create the same reaction, the beta D glucose reaction, but it comes from the boundary. That's from a pool or a sink of the metabolite. This allows the metabolite to be created from nothing. So the Cobra toolbox will recognize that we're creating this metabolite from nothing. It's allowed to enter the system. In the case of a real organism, this would be the nutrient source, which is being created and brought into the system. So we've created that reaction very quickly. And then we're able to move back into the reaction picker to hopefully have a look at our new reactions. So we've still got some filters applied, so we'll just clear the filters, and we should see the reactions pop up at the top of the reaction chooser. So there we go, we can see that the reactions that we've just created have been created. You look down at the bottom in the reaction viewer, and there they are. And we might want to add one of these reactions now to our network. We select example 3, and then we need to change the compartment that it's happening in, because this example is moving something from one compartment to another, whether it's the boundary to the extracellular or whether it's the extracellular to the cytosol. So we need to define the compartment that this reaction occurs in as a special compartment. That's just to let MetNetMaker know when it exports the reaction that it happens across a boundary. Sometimes we don't want to take all the time of defining all of our custom reactions. We'll have to do it once or twice, but Probably we don't want to have to do that in this case. It would take quite a long time. Thankfully, I've already defined all of the reactions across the boundaries that we need for this example, and that's another way where MetNet Maker can really help you. So previously I've defined all of these example reactions and used the backup user-generated reactions to create a single Excel spreadsheet which holds all the information about those reactions. And if you do that, it will also hold any information about custom compounds that you've defined. So this is loading back in the custom reactions that I've had before. Let me just press the filter button to refresh the list in the reaction chooser. And you'll notice that at the top of the reaction chooser we've got a lot of reactions that have been defined in quite a standard way, and if you want to know what any of them do, just look in the reaction viewer at the bottom and we can add those. But certainly there's this reaction here which is the alpha D-glucose transfers and the beta D-glucose transfers that I can just add straight in to my model here. And we also want the ATP and the ADP transfer reactions and the boundary reactions that are shown on in the picture. So we add all those in, all in the special compartment, all of them reversible, so they've got a maximum positive flux of 500 and a maximum negative flux of 500. And the final thing to do is add the biomass reaction that we see at the bottom, and in this case it's an objective function that is converting beta D fructose 1,6-bisphosphate to ADP, just as we see in the diagram. Now this also occurs in the special compartment. If you try and export this in the cytosol, which it does kind of occur in, then the MetNet Maker will warn you and ask you to set the compartment to special. And the only extra thing that we see here is when we open the full version of the selected reactions table, we see that the objective value has been ticked for this reaction. That's because we set the initial kinetic type to biomass or objective, and this means that when we do flux balance analysis on the problem, the linear programming solver will try and increase the flux through or decrease the flux through this objective reaction. So we've now taken the chance to export this new model that we've made as an Excel file, and we'll also export it as in a level 2 version 1 SBML file so that we can perform flux balance analysis on it later. And we see that we've got on the desktop, which is where we've sorted everything, we've got 2 Excel files, one of the top of glycolysis and one ready for FBA, and this is also the level 2 version 1 SBML file that you can open up and have a look, and it's considerably bigger because there's more reactions here.